Hello guys, welcome once more to another video again on my YouTube channel. So today we are going to be looking at partial fraction, advanced level mathematics. Okay, so as displayed to you on screen, please this video is the very first video in advanced level. So please, if you are a student preparing for the advanced level GCE examination, please, I recommend that you should look for a pen and a book so that I can actually jot down relevant points that you will find helpful in the video. Okay guys, so without wasting much of your time, let's just dive into it. Okay, so we'll be looking at partial fractions today. Okay, so what is actually partial fraction? So partial fraction is a technique for rewriting a rational function as a sum of simpler rational functions for integrations. Okay, so for example, we have 7x minus 25 divided by x minus 3 times x minus 4. Okay, so this is the resultant, this is the resultant fraction. Okay, so this is its partial fraction. Okay, so that is it. Okay, hence we say that 7x minus 25 divided by x minus 3 times x minus 4 is equivalent to 4 divided by x minus 3 plus 3 divided by x minus 4. Okay, so this sign here is very important, this equivalent sign here. Okay, yeah, it is very important. All right, so let's look at some important results when dealing with partial fractions. Okay, so we have irrational fraction. So what is actually a rational fraction? So a number, so by consideration, right? So this is, we are talking about rational fractions, but we know rational numbers, right? So a number is considered a rational number if it can be written in the form a divided by b, okay, and b should be different from 0. So if a rational number can be written in this form, therefore in a similar manner, a fraction of two polynomials f of x and g of x is rational if it can be written as f of x divided by g of x, where g of x is different from 0, and f of x and the two function f of x and g of x should have no common factor. Okay, yeah, so that is a rational fraction. Okay, so that is it. All right, so these fractions, right, two types exist actually. So we have two types of these fractions of rational fractions. There are two types. Okay, let's look at the type 1. So we have the proper fraction. So actually, what is actually a proper fraction? So in rational functions, a rational fraction, f of x divided by g of x is called a proper fraction if the degree of the numerator is less than the degree of the denominator. Okay, so yeah, look at f of x and look at g of x. G of x is in the denominator, while f of x is in the numerator. Now, if the degree of f of x is less than the degree of g of x, that fraction is called a proper fraction. And in a similar manner, if the degree of f of x is greater than or equal to the degree of g of x, that fraction is called an improper fraction. Okay, so e.g., in this case we have 6x plus 27 divided by 7x cubed minus x. So you notice here that the power of x here is 3, while the power of x here is 1. So this is actually a proper fraction. Okay, yeah, this is a proper fraction. All right, so the second case we have improper fraction. Okay, so if a rational fraction is called an improper fraction if the degree of the numerator is greater than or equal to the degree of the denominator. That is, if the degree of f of x, the degree is like the power that x is raised to, okay, yeah, the degree is like the power that x is raised to. So yeah, the degree of x here is actually 1, the degree of x here is 3, okay, so that is the degree. So don't be confused when I'm talking about degree, okay, so that is it. So looking at this example here, you notice that the degree of x is 2 and the degree of x is 3. Therefore, this fraction is considered an improper fraction. Okay, so please take note about this point here, this important result. These points here are very important, because when we'll be solving problems, you encounter when the degree of the numerator is less than or equal to, or it is actually less than, or it is greater than. Okay, so let's continue. All right, so now let's look at the procedure. Let's look at the procedure of finding partial fraction, or it depends on, you can still say method of finding partial or the whatsoever. So let's look at the procedure of finding partial fractions. Okay, so a proper fraction of the form p of x divided by f of x can be resolved into partial fraction as follows. Now there is something that's specified here. A proper fraction of the form can be resolved into partial fraction as follows. So this fraction is actually a proper fraction. Being a proper fraction, it means that the degree of x here is less than the degree of x in the denominator here. Yeah, so that is it. Now it can be resolved into partial fraction as follows. Okay, we have point A, that if f of x is a linear factor of the form px plus q, if f of x is a linear factor of the form px plus q occurs and is non-linear, that is, if f of x is a linear factor of this form, if this form occurs, right, and it is non-repeating, then its partial fraction will be of the form a divided by px plus q, where a is actually a constant whose value is to be determined. That is, when you equate a partial fraction, right, when you equate a resultant fraction to be equivalent to the partial fraction, right, that a that you assign there, or that constant that you assign there, it is a constant that you'll be actually looking for. Okay, so that is what this point is talking about. And this point here, non-repeating, means that what will be in the denominator should not be repeating, like having a power. Okay, anyways, I'll explain that better. All right, so the point B, that if in the denominator a linear factor of the form this occurs n times, that is, okay, now here they were talking of non-repeating. Now they're talking of occurs n times. So non-repeating and occurs n times actually means this other part here, the factor is actually repeating. Yeah, the factor in the denominator is actually repeating. Okay, that is px plus q all the power n. So occurs n times actually means that, like, occurring px plus q n times. So n can be 3, 4, 5, 6. Okay, so that is it. Then there will be n partial fractions of the form a1 divided by px plus q plus a2 divided by px plus q all squared plus plus an divided by px plus q all the power n, where all this a1, a2 right up to an are all constant whose values are to be determined. Okay, so I would actually like to explain this point better. So this point here is very important, and this non-repeating and occurs n times, it is very important. So this non-repeating actually means that, look at the denominator here. Okay, there is no power to which this denominator is raised to. Okay, but here there is a power to which this denominator is actually raised to, and this is the power here. So if the power occurs n times, say if, okay, let me look at it. Let me just take an example that this power occurs 3 times, okay, it means n is 3. So it means it will be a1 divided by px plus q plus a2 divided by px plus q all that squared, then plus a3 divided by px plus q all that cube. Now, since it occurs 3 times, it means you stop where the power is limited, which is 3. You cannot go beyond 3 because the power is the power occurs, the denominator occurs 3 times. Okay. Anyways, when we'll be solving the some of the examples, you actually understand it better. Okay. So let's look at the point C. Point C says if a quadratic factor ax squared plus bx plus c occurs in the denominator and is non-repeating, this point is very important, then its partial fraction will be of the form ax plus b divided by ax squared plus bx plus c. A, b constants. Okay, a, b are actually constants. Notice that the numerator is linear. So when we are dealing with a quadratic in the denominator, always make sure that your unknowns in the numerator should be your unknown in the numerator should be linear. So it means when you are dealing with cubic in the denominator, your unknowns in the numerator should be quadratic. Okay. Likewise, when you are dealing with quartic, okay, quartic polynomials, when you are dealing with quartic, it means your unknowns in the numerator should be a cubic. Okay. All right. So your equation in the numerator should be cubic. Okay, so that is it. And notice that this point here not repeating, which is very essential. So it means if the denominator is just raised to the power 1, it means it is actually not repeating. Okay. Yeah. So it means from here we can specify that n should be strictly greater than, n should not be 0 and n should not be 1. Okay, because if n is actually 1, it means we are still talking about case the a part. Okay, so n should not be 0 and n should not be 1. So n can be 2 for this case to be true. Okay, so that is it. Now let's move now to case D, point D. Okay, point D says if in the denominator a quadratic factor ax squared plus bx plus c occurs n times, that is, occurs n times means like taking what will be in the denominator and raising it to a power n, so n times, then its partial fraction will be in the form a1x plus b divided by ax squared plus bx plus c plus a2x plus b divided by ax squared plus bx plus c other squared plus a3x plus b divided by ax squared plus bx plus c other cube plus dot 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 plus an x plus b divided by ax squared plus bx plus c other n. Okay, so if you were asked to, let me say, this factor here occurs 2 times, right? This factor here occurs 2 times actually means that n is 2. Okay, and if n is 2, it means you end here, you don't go beyond this 2. Okay, so if n is 3, you end here. Okay, and if n is 4, you end where you are, where a4 will be, where your next value will be a4x plus b divided by ax squared plus bx plus c all the power 4. So that is it. All right, so let's look at the various types. So in partial fractions we have type 1, type 2, type 3, and even type 4. Okay, so let's look at the various types. All right, so type 1 is just talking about when the factors of the denominator are all linear and non-repeating. Okay, so we are going to solve some examples. We are going to solve some examples on that type 1. Okay, so this is how the question are normally set. This is how partial fractions normally come in the GCE. Okay, so I advise that please you should pay attention to these examples that I will be solving. All right, so let's look at the solution now. So this is my resultant fraction, right? And this is the corresponding partial fraction. And take note of this sign here. It's very important. Okay, so I have 7x minus 25 divided by x minus 3 times x minus 4. Okay, this is identical to a divided by x minus 3 plus b divided by x minus 4. Okay, so this is how you actually put this is the procedure that actually take when you are solving partial fractions. Okay, so that is, I just separated this this denominator here. Okay, I've just separated them. All right, notice something now. This is a part of taking the LCM. Students actually confuse this part here. Okay, but for simplicity, you can just rule your line here and then you look for the LCM. Okay, so that is actually something time consuming. Okay, what you do is just multiply everything here by the LCM. Okay, like the LCM of these two functions is actually a minus 3 x minus 3 times x minus 4. That will be the LCM, right? So if that happens, you notice that a will be multiplied with x minus 4 and b will be multiplied with x minus 3. Okay, so at the end of the day, we are going to have 7x minus 25 being equivalent to a multiplied by x minus 4 plus b multiplied by x minus 3. Okay, so if you encounter problems of this nature, how this other problem, like the problem you're solving now, right? So if you have a divided by x minus 3 plus b divided by x minus 4, what you do is just take this factor here and multiply it with this a, and then you take this one and multiply it by this other linear factor here. Okay, yeah, so that is it. So now I'm going to give some hints here that we are to note. So two methods are applicable here. So if you want to solve this from here, right, if you want to solve, we can apply two methods. Okay, method 1 is a cover-up method, while method 2 is by comparing coefficients. Okay, so I'll be using the cover-up method, but I think there will be a problem that I will use the comparing coefficient. Okay, so if I use cover-up method, cover-up method, it means I will actually choose so if I, in fact, there's no choosing here even. It's a must that you will do it. Like if I use my cover-up method, right, I will take this x minus 4 x minus 3 and equate it to 0, and therefore my x will be 3. Okay, so it means I take one of the choose either this or this, but you will do both of them. So choose the first one that you want to use, what I want to use, but this one or this one. So it depends on you. So me, I choose to use this one, x minus 3 equal to 0. So I'll put x minus 3 equal to 0. Then I make s the subject. Okay, so my x will be 3. Okay, now that my x is 3, I'll go back to this this equation here. Then I substitute 3 here. Put my 3 here. I put 3 here and I put 3 here. Okay, so at the end of the day, I'll have 7 times 3 minus 25 being equal to a multiplied by 3 minus 4 plus b multiplied by 3 minus 3. And what do you notice about 3 minus 3? 0. And 0 multiplied by b is actually 0. Now 3 minus 4 is actually negative 1. Yeah, and negative 1 times a is actually negative a. Okay, and then 3 times 7 times 3 is actually 21. 21 minus 25 is negative 4. Okay, so at the end of the day, I have negative 4 being equal to negative 1a, and therefore my a is just equal to 4. So that is it. Please, I hope it is really clear, because maybe you can be having some doubt somewhere. Anyways, you can still reach me in the comment section, or you can reach me on WhatsApp. Okay, so let's continue. All right, so now this is my first case. Now for my second case, I'll put x minus 4 equal to 0, and then I solve for x. so my x will give me 4. Okay, then I take my 4, my x being equal to 4, it means I'll substitute my 4 in a place where I'll find x. Okay, from here. So my x is 4. It means I'll put 7 times 4 minus 25 equal to a into 4 minus 4 plus b into 4 minus 3. So at the end of the day, we have this. Okay, so that is it. Now, so if we multiply, notice something here. Here we know that 4 minus 4 is actually 0. Okay, and 0 multiplied by a is 0. Okay, and 0 again plus this term here is still this term. Okay, so I notice again that 4 minus 3 is actually 1. Okay, so at the end of the day, we'll have 3 being equal to 1b implies b equal to 3. Okay, because 7 times 4 is 28. 28 minus 25 is 3. Okay, and here is 0. So 4 minus 3 is 1. That's why I have 3 being equal to 1b. Or you can just write 3 equal to b, depends on you. And therefore my b is 3. Okay, I decided to put this one here for clarification, because notice something here. If I just put -4 being equal to -a, it looks somehow, some people might be actually confusing. So that's why I decided to include the one there. Okay, yeah, so that is it. Okay, knowing the values of a and b, hence the required partial fraction is 7x minus 25 divided by x minus 3 times x minus 4, being equivalent to, since my a is 4, so I'll put 4 there. Where I find my a, I put 4, and where I find my value of b, I put 3. Okay, so my value of b is actually 3, and I put my 3 here. So this is it. That so this resultant fraction here, the partial fraction is this. Okay, this is a partial fraction of this resultant fraction. Okay, so that is it. All right, let's continue. Okay, example 2. Resolve into partial fraction 6x cubed plus 5x squared minus 7 divided by 3x squared minus 2x minus 1. Okay, so this is where that part comes in. The part where I was actually emphasizing on the important results. So you notice something here, that the degree of x in the numerator is greater than the degree of x in the denominator, and therefore this rational fraction is improper. Okay, but for us to resolve this fraction, we must make sure that it is a proper fraction. Okay, so what are we going to do here? Questions of this nature, or if you encounter problems of this nature, make sure that you always check the degree of x in the numerator and in the denominator. Okay, now if you notice that the degree in the numerator is greater than or equal to the degree in the denominator, it means you have to do what we call the synthetic division. Okay, so anyways, I will be solving while explaining. All right, so let's look at the solution. Now, synthetic division, commonly called long division method, is the method that we are going to apply here. Okay, so let's look at it. So now, since the degree here is more than the degree in the denominator, it means I'll take this term here, I'll take this divided by this. Okay, so I'll take 6x cubed plus 5x squared minus 7 divided by this. Okay, so I will place this 3x squared minus 2x minus 1 here, and then I place this other term here inside the division sign. Okay, so that is it. Now I can actually tell you that you should actually pay attention here, because this synthetic division actually is disturbing most students. Okay, so let's tackle it step by step. Okay, so now this is our synthetic division that we are about to carry out. Okay, or the long division method. Okay, so this is it. Now what I will do now is I will take the first term here, this first term 6x cubed, and then I divide it with 3x squared. Now 6 divided by 3 is 2. Now 6x cubed divided by 3x squared. So notice that this x squared will cancel with this other x squared here, and 1x will be left. And 6 divided by 3 is actually 2. Then times that x that will be left is 2x. Okay, so I'll place my 2x here. Okay, so that is my 2x. Now the next step is you take this 2x now, you take this 2x now, and then multiply it with all this term here. Okay, such that 2x multiplied by 3x squared will give me 6x squared, 6x cubed. And then 2x multiplied by negative 2x will give me negative 4x squared. And then 2x again multiplied by negative 1 will actually give me negative 2x. Okay, some people might be wondering where this 0 is actually coming from. Alright, so it's good that I actually figured out. So let me explain why this 0 is here. Notice something, that this is a cubic polynomial in which the power, the degree of x is actually dropping by 1. Okay, yeah, it's actually dropping by 1. So here is the degree, here is 3, here is 2. It means that the next one should be 1, but it was not given in the equation. So you just have degree 3, degree 2, and there's no degree 1. So I decided to include this 0x here, such that my degree of x here now is actually 1. Okay, so because if this is not done, it means that you cannot carry out the synthetic division. Okay, you cannot carry out the long division. That is why I included this 0x here. Anyways, now if I take this negative 2x, then I multiply it with this negative 1, I'll have negative 2x. Okay, so at the end of the day, I'm going to have my result as this. Okay, so 2x times 3x squared is 6x cubed. 2x times negative 2x is negative 4x squared. And then 2x times negative 1 is negative 2x. Okay, so that is it. Now here, I just have to subtract. Okay, I just have to subtract. It means I'll subtract this, I subtract this, and I subtract this. Okay, so that is it. Now 6x cubed minus 6x cubed is actually 0. Okay, and then 5x squared minus 4x squared is 9x squared. Okay, and then 0 minus minus 2x is actually positive 2. Okay, so then I'll bring down this negative 7. So at the end of the day, I'll have this. Okay, so that is it. I hope it is really clear. So that is it. Now I will still take now this 9x squared. Okay, I will take this 9x squared, and then I'll divide it by this 3x squared. So the same procedure here goes here, and we goes to the next stage if at all it will be possible. Okay, so that is it. So I'll take 9x squared divided by 3x squared. So 9 divided by 3 is 3, and x squared divided by x squared is 1. Therefore 9x squared divided by 3x squared will actually give me 3. Okay, so I'm going to place my 3 here. So that is it. Now I take this 3 again, and then I multiply it through all this term here. Okay, so 3 times 3x squared is 9x squared. 3 times negative 2x is negative 6x, and 3 times minus 1 is minus 3. So at the end of the day, I'm going to have the result as this. Okay, now I'll do my subtraction again. So 9x squared minus 9x squared is 0. Now 2x minus 6x is 8x, okay, and then negative 7 minus 3 is actually minus 4. So at the end of the day, I'll have this as my my values, okay. Now notice that I cannot take 8x now and then I divide it again by 3x squared. No, because this term here is actually linear, while this term here is a quadratic, okay. That is why I cannot take 8x minus 4 divided by 8x divided by 3x squared, okay. This is linear and this is quadratic. So this they use this to divide, it by this. They use this cubic polynomial to divide it by this quadratic polynomial, because the degree here is actually more than this one. But here, and then even here, you notice that they still use this quadratic here, this polynomial here, to divide with this other quadratic polynomial here, okay, this polynomial of degree 2, and then they use this other one to this other polynomial of degree 2 to divide it with this other one, because according to the important result that I just explained earlier, I said if when the coefficient of degree of x here is greater than or equal to, means if it is greater than or it is equal to the degree of x in the denominator, it means we will still carry out a synthetic division. That is why the degree here is 2, the degree here is still 2, so it means the 2 degrees are equal. That is why I still carry out the long division again. That is why I took 9x squared divided by 3x squared again. But here, now the degree here is less than the degree now here. That is why we cannot no longer do the division again, okay. So at the end of the day, I'm going to give some hints. So I've just actually resolved this now, okay. So for my hints, we have the dividend divided by the divisor is equal to the quotient plus the remainder divided by the divisor, okay. So this is actually the quotient. This is my dividend and this is my divisor, okay, and this is my remainder here, okay. So that is it. So this hint here is going to be used in the next slide here, yeah. So hence 6x cubed plus 5x squared minus 7 divided by 3x squared minus 2x minus 1 is equivalent to 2x plus 3 plus 8x minus 4 divided by 3x squared minus 2x minus 1. So that is it. But notice that we have not still yet expressed this as a partial fraction, okay. So there is this other term left here, so we can actually just figure out this other part here. We can take this part here and then express it into partial fraction again, while leaving this other term here, without touching it, okay. So notice that 8x minus 4 divided by 3x squared minus 2x minus 1 is just equal to 8x minus 4 divided by x minus 1 times x minus x plus 1, okay. It means I've just factorized here. Now if you look for two factors, if you look for two factors in which if you multiply we give you AC, so this is my A, this is my B, this is my C. So if I look for two factors in which if I multiply will give me AC, AC means A times C, which is -3, and then if I add that two factors will give me -2. It can only be -3 and 1, okay, or yeah, -3 and 1, or 1 and -3, yeah, it should be 1 and -3, yeah. So that is it. And then you notice that this time it is equivalent to A divided by x minus 1 plus B divided by 3x plus 1, okay. As I earlier explained in the last example, yeah, don't bother for you looking at LCM is actually time consuming. Just take this term, this linear expression, this linear factor and multiply by a, and then you take this other linear factor and multiply by b, and then equate it to this other part here. Okay, so at the end of the day, we are going to have ax minus 4 equivalent to a multiplied by 3x plus 1 plus b multiplied by x minus 1. Okay, so this equivalent sign is still used here, but when using a cover-up method by comparing coefficient, the equivalent sign will not longer be there. Okay, we use by the equality sign, this normal equal sign here. Okay, so by the cover-up method, means I will choose it, I'll begin either from this one or from this other one here. Now if I begin with this one, it means I'll put x minus 1 equal to 0 and my x will give me 1. Okay, and if my x give me 1, it means I'm going to substitute this value of x back into this this expression here. Okay, so at the end of the day, I'm going to have 8 multiplied by 1 minus 4 being equal to 3 into 3 times 1 plus 1. Okay, then plus b into 0, since if I put 1 here, 1 minus 1 is 0. Okay, so that is it. Now 8 minus 4 is 4, and all this is 4. That is 3 times 1 is 3 plus 1 is 4, and then 4 multiplied by a is 4a. Okay, implies that my a is just equal to 1. Okay, so that is it. And then I can actually look now for my b. Now this is my value of a. Now I'm looking for my value of b. Now I can actually put my x. I can put 3x plus 1 equals to 0. It implies that finding my x will just give me negative 1/3. Okay, so that is it. Now I take this negative 1/3 and then I substitute it here. Okay, so at the end of the day, I'll have 8 times negative 1/3, because my negative 1/3 is my x. So where I see my x, I'll put negative 1/3. 8 times negative 1/3 is it here, minus 4 equal to a times 3 times negative 1, a into 3 times negative 1/3 plus 1. So here my x is negative 1/3, then plus 1, then plus b into negative 1/3 minus 1. Okay, so if I simplify this here, I'll have negative 8 divided by 3, then minus 4 being equal to, if I simplify this, I'll have negative 4 divided by 3. Okay, and then no, sorry, if I simplify this, I'll have 0. Yeah, it is clear, because if I take 3 multiply with 1/3, this 3 will cancel with this other 3 here, so I'll be left with negative 1, and negative 1 plus 1 will just be 0. Okay, and then if I take negative 1/3 minus 1, it will give me negative 4/3. Okay, so if I simplify this other side of the equation, I'll have negative 20 divided by 3 being equal to negative 4/3. Okay, negative 4/3 b. Okay, so if I divide all through now by negative 4/3 b, then I divide this side 2 by negative 4/3 b, it will cancel here, and here this 4 here will reverse. Okay, anyways, that's not really the matter. Just punch it on a calculator. You have that b is equal to 5. Okay, cannot be explaining this stuff here. All right. Okay, now since a equal to 1 and b equal to 5, therefore the required partial fraction is this. Okay, but notice that we have not still decomposed this completely into partial fraction. Okay, but since we have had this part done, and this part, therefore the required partial fraction is given by this. Okay, so that is the required partial fraction. Okay, so that is it. All right, I hope it is really clear here. Please, this part is very important here. This when the coefficient of x is greater than or equal to the degree in the denominator, please, it is very important, because when you'll be doing partial fraction by integration, that is, they will give you a partial fraction like this, then they will ask you that, hence integrate it, integrate this required partial fraction that you have resolved like this. They will give you the integration, they will give you integral sign with the limits of integration, like substitute for you to have some for you to have a certain proof. Okay, all right, so let's look at type 2. So type 2 says when the factors of the denominator are all linear but some are repeated. This point here is very, very important. Some are repeated. Okay, so let's look at examples while I'll be explaining. All right, example 1, we have resolve into partial fraction x squared minus 3x plus 1 divided by x minus 1 squared times x minus 2. Yeah, students actually confuse if they want to write the unknown partial fraction in which there is an unknown variable there. Okay, so students actually confuse this part here. Anyways, let's tackle the solution so that I'll be explaining. Okay, so yeah, this is the part I was actually saying. Okay, notice that when the factors of the denominator are all linear but some are repeated. Okay, some are repeated. Look at this factor, it's actually a repeated factor according to the important results that I was explaining. I think that should be point Z like that according to the previous slide. Okay, so look at something here. Some students just come and then they put this and then they say a divided by x minus 1 squared plus b divided by x minus 2. So if you do it that way, you actually feel the problem, because it is clear that this factor is a repeated factor. Okay, so repeated factor means you n where the power ends also. It means you do it, let me say n, so you do it n times. That is why I was actually emphasizing on that point concerning that n times and non-repeating. Okay, so that is it. Now that it is a repeated factor of degree 2, it means that I would do this 2 times. So I have it 1 time and then I have it 2 times. If here was 3, I'll have it 1 time, 2 times, and then 3 times. But it is 2. That is why I just have it 2 times. Okay, so that is it. That is it. All right. So yeah, that is it. Now this part here, I decided to do the LCM part because I would like to explain some relevant things here, because here students actually make some mistakes that are not actually good. Okay, yeah, they usually make some mistakes here, so I decided to explain this part well. Okay, so let's look at it. Now these are my unknown partial fraction. This is my partial fraction with unknown variables a, b, and c. Okay, so yeah, I would actually look for my LCM. There is a point I want to emphasize here. My LCM. Okay, so if I rule my line, so my LCM now would be negative x minus 1 all squared multiplied by x minus 2, not x minus 1 multiplied by x minus 1 all squared then multiplied by x minus 2. No, my LCM is just x minus 1 all squared then multiplied by x minus 2. Okay, so that is my LCM. Now now this is my LCM, right? Now I'll take this my LCM and then I divide it by this other this other factor here. Now if I take my LCM and divide it with this factor, you notice that one of this factor will cancel with another one of this factor here. So at the end of the day, we left with x minus 1 times x minus 2. Then they will multiply that x minus 1 times x minus 2 now with a. So I will have a multiplied by x minus 1 multiplied by x minus 2. Okay, so now I'll go now to the next step. I'm here. Okay, I will take now x minus 1 all squared times x minus 2 and then I divide it by x minus 1 all squared, and you notice that this x minus 1 all squared will cancel with this x minus 1 all squared, and I'll be left with x minus 2, and then the x minus 2 now will be multiplied with b. Okay, so at the end of the day, I will have positive b multiplied by x minus 2. Okay, then I'll move now to the last case here. So I'll take this x minus 1 all squared multiplied by x minus 2, divide it with this x minus 2. X minus 2 will cancel with this other x minus 2. So my c will multiply with x minus 1 all squared. Okay, so that is it. Now what to do now is, you notice that sorry, there was supposed to be an equivalent sign here. You notice that this denominator x minus 1 all squared times x minus 2 is also found here. X minus 1 all squared, x minus 2. Okay, so they actually cancel out, and if they cancel out, I'll have that x squared minus 3x plus 1 is equivalent to all this. Okay, and I can call this equation 1. There is a reason for that. The reason for this equation 1 is just for substitution purposes. Okay, for substitution purpose. All right, so now I can actually use my cover-up method. I think I will use the alternative or comparing coefficient together with the cover-up method. Okay, so by the cover-up method, if I put x now, by the cover-up method, there are alternatives here. I can put x minus 1 and then x minus 2. Yeah, I can put x minus 1 and x minus 2. Now, if there was x minus 3 also, I can also put x minus 3. Okay, so by the cover-up method, I put x minus 1 equal to 0, implies my x equals to 1. Now, I'll put it now in equation 1. So this is my equation 1, I'll put it here. If I put it there, I'll have this. Okay, I'll have my x equal to 1, right? So where I see x, I put 1. I'll put 1 squared minus 3 times 1 plus 1 equal to a. Now if I put 1 here, 1 minus 1 is 0. That's why I have 8 multiplied by 0. I put 1 here, 1 minus 2 is negative 1. Multiplied by negative 1, then plus b. This is my b here. If I put 1 here, I have negative 1. Okay, and then I put 1 here, I will have 0. Okay, so at the end of the day, I have that negative 1 minus 3. 1 minus 3 is actually negative 2. Negative 2 plus 1 is negative 1. Okay, and then all this will turn to 0. This will also turn to 0. And then my negative 1 multiplied by b, I have negative b. And therefore, my b is just equal to 1. Since I will divide all through by negative. And negative will cancel this one negative here. Okay, so my b is just equal to 1. Okay, so now I can use the cover-up method in a similar manner. If I put x equal to negative 2, x equal to 2y, because I will put x minus 2 equal to 0, and I solve for x, and my x will give me 2. That is why I have x equal to 2 here. And then I substitute it now in equation 1. In this equation 1 here. So I'll have this. So where I see x, I'll put 2. So I have 2 squared, because there's x squared here, minus 3 into 2x into 2. So I have 3 times 2, since my x is 2, then plus 1, being equal to a times, what is my x? My x is 2. A times 2 minus 1 times 0, because if I put 2 here, 2 minus 2 is 0. So it means this term will actually fall out, and this is b, right? So I have x, but my x is 2, so I have 2 minus 2 is 0. So this term 2 will also fall out. Okay, so I'll be left with c. So I put 2 here, 2 minus 1 is 1, and if I square 1, I'll still have 1, and then I multiply the 1 by this c, I will still have c. Okay, so at the end of the day, I have 4 minus 6 plus 1 being equal to c, and implies that my c is equal to negative 1. How? 4 minus 6 is negative 2. Negative 2 plus 1 is negative 1. Therefore, my c is negative 1. Okay, so that is it. Now, since I have my a, I have my b, I have my b and my c. Now it means I'm looking for my a. So for me to look for a, I will actually use the method of comparing coefficients. Okay, so I want that you should be familiar with this other method too. So by comparing coefficient means that I'll come here, these two factors here, I'll multiply them or I'll expand them. Now if I expand them, I'll have x times x is x squared, right? Then I have x times negative 2, I have negative 2x, and then x times negative 1 times x, I have negative x. Negative 2x minus x is negative 3x. Okay, then if I take 1 times negative 2, negative 1 times negative 2, oh, here was supposed to be negative. Here was supposed to be negative. Was supposed to be 2. Sorry for that error. Here was supposed to be 2. Supposed to be 2 here, and not here. Here it's supposed to be 2. So 1 times negative 1 times negative 2, I'll have positive 2. Okay, so that is it. Now I move now to the b. The b, there is no term for me to expand, right? So I'll just, there's no other factor for me to expand with this other factor here, so I'll leave it like that. There's no other factor like in case of a here, so yeah, I'll just leave it like that. Now I move to c, the c part, to a part containing c. Okay, now I have x minus 1 all squared, right? So x minus 1 all squared means that you take x minus 1 times x minus 1. So if you take x minus 1 times x minus 1, you have this x squared minus 2x plus 1. Okay, so that is it. Now I can compare coefficients, but notice that I already have my value of a and my value of b and my value of c. My b is 1 and my c is negative 1. So by comparing coefficient, I will start with a term containing x squared. Okay, I'll start with a term containing x squared. Now if I compare the coefficient of x squared, right, in this other part, okay, this other part here, my coefficient of x here is 1. Okay, my coefficient of x here is 1. That is why I put 1 here. And then in this part containing a, right, my coefficient of x squared here is a, because if I take a times x squared, I'll have ax squared. So the coefficient here is a. That is why I put my a here. Okay, now for the part since there is no square term here, it means this b will fall out here, since there is no square term there. Okay, now for the c part, if I take my c and multiply with this x squared, I'll have cx squared. So that means the coefficient of x squared here is also c. Okay, now I have 1 equal to a plus c. Okay, yeah, I have 1 equal to a plus c. So it implies that if I make a the subject from here, I'll have that my a will be equal to 1 minus c. And what is my c? My c is negative 1. Therefore, my a will be 1 minus negative 1. And 1 minus negative 1 is, let's say, 1 minus minus 1. Minus minus will give you plus. Okay, so at the end of the day, my a is just equal to 2. Okay, so that is my a. So now I know my a, means now I know my a, I know my b, and I know my c, and therefore this partial fraction can be written with respect to this my values of a, b, and c. Okay, so that is it. All right, hence the partial fraction is this. Okay, notice that here is plus, but here is minus. You might be wondering where this minus is coming from. Don't forget that our c here is negative. This is it here. Our c is negative 1. So if I put negative 1 here, the negative will actually come here, because negative times positive is negative. So if I put negative here, the negative will multiply with this positive, and the result will give me negative. That is why there is a negative here. Okay, so that is it. All right, let's continue. Okay, so I have example 2. Example 2 says resolve into partial fraction 2 divided by x cubed times 2x plus 1. Okay, so that is it. Now let's look at the solution. So we have 2 divided by x cubed times 2x plus 1. Now this is another case where the denominator is a repeated factor. Okay, the denominator is actually a repeated factor. Notice that here the repeated factor here is of power 3 of degree 3. It means I will do it 3 times before doing this other part here. Okay, so it means I will do a divided by x 1 time plus b divided by x squared 2 times, then plus c divided by x cubed. Then I will end here because the power here is, the degree here is 3. I will end here, then before doing now the other part, the z part. Okay, so that is it. And that you can also do your LCM here, but it depends on you. Okay, if you know you have understood the other part where you just take this and multiply with this, take the other one and multiply the other one, you can just do it there. It depends on you. But for the sake of watching this video, right, I recommend that you should actually do this part here. Okay, so that you actually master the concept very well. Okay, so that is it. Now I think the video is too lengthy and I don't think I will continue this part, so I'm going to leave this part as an assignment. Okay, I'm going to leave it as an assignment so that I can present a solution either through WhatsApp or in the comment section. Okay, so continue the part as an assignment. Okay, so this is the end of the video. Okay guys, see you in another video.